Hi there. So in this question, what we're going to do is do a limiting reagent question. And we're going to start by writing a balanced equation. So methane is CH4. We're going to add it to oxygen. And during a combustion, you make CO2 and water. All right, then we have to balance it. So there's one carbon on each side. There's 4 hydrogens on the left. So I need to add a 2 here. This totals to 4 oxygens, so I need to add a 2 there. And then what we're going to do is look at our initial conditions. So we have 10 liters of methane. And because they tell us that this is at STP, we know that for every mole of any gas at STP, there's 22.4 liters of that gas, right? And then we use the mole-to-mole ratio in the balanced equation to get from CH3 to CO2. So for every 1 mole of CH3, there's 1 mole of CO2, and then we go back to liters. So for every 1 mole of CO2, there's 22.4 liters of CO2. Multiply across the top, divide by the bottom. What we end up getting is 10 liters of CO2. All right, we check to make sure all of our units cancel, which they do. But we are not done. Now we have to look at the other reagent. So for 18 liters of oxygen, we do the same conversion. There's 22.4 liters of oxygen in 1 mole. All right, now that only works at STP. Otherwise, you would have to use the ideal gas law, but we don't have to here. And then we use our balanced equation. So for every 2 moles of oxygen, there's 1 mole of CO2. And then for every 1 mole of CO2, there's 22.4 liters of CO2. Here we multiply across the top, divide by the bottom. All right, we notice that those 22.4s cancel. We get 18 divided by 2, which is 9 liters of CO2. The lower number is your final answer because the oxygen will run out first and we'll make that much CO2. And so we would call the oxygen the limiting reagent, and the methane is the excess reagent. And that's the end of the problem.